Okay, to finish up components of vectors, what I'd like to summarize with is that the x component can always be found by taking the magnitude of the vector times the cosine of the angle as long as theta is with respect to the x-axis at 0 degrees. The y component can always be found by taking the magnitude of the vector times the sine of the angle, again, as long as theta is with respect to the x-axis. So this vector, 3,750 newtons in length, I'm even going to kind of draw real quickly where this is. So 217 degrees is in the third quadrant. Let's see if this is 180, 200, 217. This vector is about right here. That's where that is. And we are looking for its x component and its y component that make up the vector itself. So we can see that the x component is going to be negative, and so is the y component going to be negative. Also, that's because we're in the third quadrant. But I'm telling you that this formula up above, if you take the magnitude of the vector times the cosine of 217 degrees, you will get the length of this line, which is going to be negative, and it's probably going to be longer than the y value. If you take 3,750 and multiply it by the sine of 217 degrees, it's going to be negative, but probably a little bit shorter than that x value. Let's check it out. So let's go 3,750 times the cosine of 217 degrees. Again, I said it should be negative. Let's check 3,750 times the sine of 217 degrees. That should be negative because of the picture, but also remember the only trig function that's positive in the third quadrant is tangent. So both cosine and sine in the third quadrant are both negative. I'm going to try to remember these numbers. 2994 and 2256. 2994 and 2256. They were both negative. I'm going to go back and see if I got them right. 2994. Probably should have put 95 and 57. You know, I should have had 95 here and 57. But I do have this x component that's larger than this y component using these statements. This 52-degree angle, you're just talking about a vector that's in the first quadrant. It's at 52 degrees. It's kind of small in length. It's 0.54 is its length. So that's the magnitude. It's in units are feet per second. But this angle right here, 52.7 degrees. And what you're looking to find, again, is this x component and this y component. So again, the x component is found by taking the magnitude of the vector times the cosine of that 52.7 degrees, and the y component is found by taking the magnitude of the vector times the sine of 52.7 degrees. I'm not going to calculate those values. You can check those out. But since 52 degrees is beyond 45, it's beyond halfway, the x component should be smaller than the y answer. Because at 45 degrees, these lines would be exactly the same because they're part of an isosceles right triangle. Let's talk about this last question. Two upward forces are acting on a bolt. One force of 60.5 pounds acts at an angle of 82.4 degrees above the horizontal. The other force, 37.2 pounds, acts at an angle of 50.5 degrees below the first force, All right, that's a challenging problem. I'm going to have to draw this. I think I'll draw this picture right here. It's all in the first quadrant, so I'm showing just the first quadrant. The first vector is at 82 degrees, so very close to the y-axis, which would be 90 degrees, and it's 60.5 pounds in length. So this one right here is the 60.5 pounds. The 37.2 pounds acts at an angle of 50.5 degrees below the first force. So and it's not as long. It's 37. I wish I had done that with a straight line. But this angle right here is 50.5 degrees. If this angle right here was 82.4 degrees, then we could subtract those two and find the acute angle right here that the 37.2 pounds is at. And I'm afraid I didn't do that in advance. So let's see, 82.4 minus 50.5. If I wasn't doing a video, I could probably do this in my head. So that's at 31.9 degrees. It wants to know what the total upward force is on the bolt. Now both of these vectors are pulling on the bolt. I'm going to draw this one and make it dark again. Well, an upward force would be something that's going in the y direction. So what I want is the y components of each of these. Let's call the first one A. So it would be 82.4 times the sine of the magnitude of that vector is 60.5 pounds, and the angle is the 82.4 degrees. The other vector's magnitude is 37.2 pounds, and its angle is 31.9 degrees. Those two pieces make up the upward force. They make up, for this vector right here, that's the upward force, and for this vector right here, that's the upward force. Let's go find out what these are. I see that this one should be bigger. If my drawing is correct, this one should be bigger, this one should be smaller. So let's check it out. So the first one, let's see if I can show this on the screen, is 60.5 times the sine of 82.4 degrees. So about 60 pounds of force acting upward. That's because it's practically at 90 degrees. It was at 82 degrees. So the most of its force is upward. The other one is 37.2 pounds times the sine of 31.9 degrees. And that one should be, a good bit smaller. Remember what our picture looked like? So the blue one is the 60. The 19.6 is this other, and the total upward force is approximately 60 and 20, if you wouldn't mind my doing that. I'm just going to estimate those since I've said it out loud. So this one's approximately 60, and this one's approximately 20. So the total upward force is approximately 80 pounds on that bolt. We'll continue in the next section by actually adding vectors in their full mathematic completion. So we're going to be finding the x and y components. We're going to be using the Pythagorean theorem, etc., to find the length of the sum of two or more vectors.